The students from the Faculty of Technology, Faculty of Civil Engineering and Technology, UniMAP, from the class of AMJ 31804, Air Pollution Control Engineering, and also from FKTA staffs. Ada juga from, I believe from across universities, okay? It is with great pleasure that I welcome all of you today's webinar. It's on an issue of utmost importance, which is microplastic in the atmosphere, and also the overview of microplastic in freshwater sediment. So inshallah, with me today we have two speakers, which are Dr. Noorlin Binti Mohamad and Dr. Maisarah Binti Jaafar. They are both from the Microplastic Research Interest Group, MRIG, and both are currently senior lecturers with the Faculty of Sciences and Marine Environment, University Malaysia, Terengganu. Okay, welcome to our monthly webinar, Dr. Noorlin and also Dr. Maisarah. Okay, before we start, insyaAllah, we shall recite Ummul Kitab Al-Fatihah. Yeah? All right, so at the end of the program, okay, I will post here the attendance Google form, okay, so that we can issue a certificate lah, for attending the whole talk. All right. Before we start, shall I introduce our panel first? Okay, our speaker. Okay, so here we have Dr. Noorlin. Dr. Noorlin, ada tak Dr. Noorlin? Dr. Noorlin Mohamad.
Assalamualaikum and good morning all.
Waalaikumsalam warahmatullahi. Okay, Dr. Noorlin is currently a senior lecturer from the Faculty of Science and Marine Environment, University Malaysia, Terengganu. She is currently a secretary.
Yep, secretary of MRIG.
Of MRIG, Microplastic Research Interest Group. MRIG ni is a prominent group lah in Malaysia, working on the microplastic research lah. Alright, also we have Dr. Maisarah. So before that, Dr. Noorlin tadi is dia punya area of expertise is in air pollution monitoring lah, especially microplastics. Also we have here Dr. Maisarah Binti Jaafar. She holds a Doctor of Philosophy in Analytical and Environmental Chemistry from the University of Surrey, UK. So her area of expertise is various, okay, including method development using ICP-MS and GFASS, trace elements of metal speciation using field-based solid phase extraction ICP-MS, environmental monitoring, food contamination of toxic trace elements, bioremediation of trace elements, as well as microplastic contamination. Okay, before we start, I shall introduce sikit lah on the microplastic. So the introduction of plastics in our modern world currently has created an environmental threat of microplastic. Microplastic, as we know, for example, plastic bags, bottles, okay, has long been recognized as a global environmental issue. But we can't deny that the hidden realm of microplastics unveils a new dimension of pollution and challenges our understanding of plastics' impact on the environment. So the alarming reality is that microplastic have the potential to disrupt the balance of our environment in numerous ways. For example, in aquatic ecosystem, these particles are ingested by marine organisms. In atmosphere, it can easily enter our human respiratory system, while in soil, it can affect the fertility of soil. And many other environmental threats that we don't know yet the impact to us lah, and also to the biosphere. So thus we are here today to listen to our both speakers in understanding what is actually microplastics and how it can affect us. Okay. So without further ado, I would like to invite uh, our first speaker, which is Dr. Noorlin Mohamad.
Sorry, Dr. Sara. Can I pass this presentation to Dr. Maisarah first?
Okay, can.
Alright, thank you.
Okay. Maybe Doctor will start with the first topic, okay, which is on the overview of microplastic in freshwater sediments. So later on, we'll be hearing from Dr. Noorlin, microplastic in the atmosphere. Okay, silakan Dr. Maisarah.
Okay, Assalamualaikum and good morning to all. Boleh dengar ke suara saya?
Boleh.
Sebab saya punya laptop tu tak function, dia punya speaker tak tahu kenapa tak boleh. So
Sekarang boleh.
but I need to use both lah, my phone dengan my laptop. So yeah, if you cannot hear my voice, just please tell me, yeah. Okay, alright.
Okay, no
So
problem.
okay, let me share the slide presentation first. Okay. Sekejap doktor.
Boleh.
Okay, dia tak keluar pula yang saya punya slide tu. Kenapa?
Doktor kena share ni kot screen.
Entire screen.
Yes.
Tapi dia tak keluar yang kita nak tekan tu. Macam mana?
Dekat bawah tu yang present now tu ada tak?
Dah. Tapi dia tak keluar pun the presentation
Tak ada.
PowerPoint. Tak ada. So macam mana?
Ataupun doktor share slide tu ke WhatsApp saya ke, nanti saya share.
Okay, sekejap. Saya share pada Dr. Noorlin.
Boleh.
Okay,
Nanti throughout the talk atau webinar nanti, okay, whoever have any questions, you can also type in the call messages.
Yes, please. Okay, dah ke?
Okey, sekejap saya baru dapat.
Saya tak tahu kenapa dia hanya keluar yang window saya je. Dia tak keluar yang kat screen saya lain.
Okey, boleh nampak tak ni?
Boleh?
Okey, kalau saya change slides, nampak tak?
Nampak?
Baik, okey.
Okay, so Assalamualaikum and good morning everyone. I'm so sorry for the technical problem. Okay, first of all, I would like to thank Dr. Sara Yasina for the brief introduction and for the invitation. I was so honored to be here as one of the speakers for today. So I would like to share some of the information and my knowledge on microplastic in freshwater sediment, specifically in ASEAN country. Doctor, can you move to the next slide, please? Okay, so before we begin, let me ask you a question. What do you know about plastic? What do you have in mind now? So when someone asks you what is plastic, so what in your mind first come up? Anyone?
Plastic pollution.
Okay, plastic pollution. So before we go to further to plastic pollution, so first we need to know what is plastic. So what is plastic? So plastic, if I guess everyone, if you're talking about plastic, you will thinking of plastic from the packaging, right? Food packaging, or you go to pasar malam, you have the plastic, with or so-called we call as a single-use plastic. So those are categorized as a plastics. But what is exactly the plastic? So the plastic is a synthetic polymer. Next slide, doctor. Okay, so the synthetic polymer that consists of repeated unit. We call it monomer that consists of a long chain of carbon atom backbone. So it can be any atom to attach with the carbon atom backbone. So could be nitrogen, could be sulfur. So that's made the plastic different. I mean, you can have a different type of plastic. For instance, LDPE, nylon, polypropylene, polystyrene, and etc. So what is so special with plastic? So plastic has unique traits. So if you guys can guess, what do you think about the unique traits? What are their advantages above all other traditional materials? Why they can like apply in wide variation of applications? So what do you think? What is
Yes,
that?
it
Sorry?
can withstand a lot of heat. It can last forever.
Mm-hmm. Okay, so meaning that they has special. They are special. They not only has a lightweight, but they also cheap. They are versatile, meaning that they can be mold, they can be shaped, depending on their needs, meaning that what are their end application. So that's some of their, and then durability means that they're like is very, they has a strength. Okay, so with that unique traits, they are not easily degrade in the environment. So with that in mind, they supposedly to cause or pose significant impact if they are released into the environment, right? So can we go to the next slide, please? Okay, so why is plastic a problem? Just now we know that plastic have a lot of advantages, but why plastic is a problem? That's because with massive production of plastic, for instance, 2018, world produced 359 million tons of plastic, and the number increasing almost 100% 1 year later. So that's show that the demands of the plastic is quite high, because I guess we as a in the modern society, we need plastic in many parts of our life, right? Like for example, if you buy from Shopee or maybe TikToks, okay? So if you buy, you do some shopping online, sending your things or your materials with plastic, right? So we need a lot of consumption of plastic. So in fact, in our in terms of food, okay, so food preparation and packaging, we use a lot of plastic, because plastic, like I said before, they have a lot of advantages compared to other material. So what happened here with that massive production, mostly coming from Asia, 51%, where 31% coming from China, meaning that China produced the plastic 31% of the world production. So majority of the plastic production is coming in the Asia. So just imagine that if we produce more, meaning that we produce more waste, right? Okay, so in terms of industry, majority of the application in the packaging, okay? So others also have lah, kan? So here we have textile, of course, textile a lot lah. And then we have transportation and etc. So next slide, please. But what happened when we produce massive amount of plastic, but unfortunately, we poorly manage the plastic. So it become mismanaged. So we produce a lot, but we cannot deal with the waste properly. So end up, we emit a very high amount of plastic waste, okay, in the environment. So if you can see from this map, okay, so you can see the red color. So it's most of these coming from ASEAN country, okay. So if you go further, you can see that from that ASEAN country, most of them is coming from ASEAN country. Thailand, Malaysia, Philippines, Indonesia, Singapore, Sri Lanka is part of the ASEAN country, okay? So, next, Doctor. So, with that in mind, you see this list, okay? We can say that the top 10 of the on the rank is dominated by ASEAN country, okay? So, for instance, number 2, okay, we have Indonesia. Malaysia ranked number 8 here. This is the study done by Jambek, okay, back to 2015. But, Doctor, next slide. Okay, so we have here from 10, 6 out of 10 is from ASEAN country. So, next, Doctor. So, what is the current scenario? So, in 2021, Niger et al. Has modeled the highest ocean plastic waste polluter from they use the literature to model which country contribute the most significant one in terms of plastic waste. Okay, so from their study, they find out that because of the mismanagement of plastic waste, the top 10 are from nine countries of ASEAN. Okay, so then from that nine country, 6 out of the 9 is from ASEAN country, meaning that we also included in that. So Malaysian before in 2015 we are on the rank number 8, but now we are on the 3rd place. Okay, so meaning that we are like increasing our not only production, also our waste. Okay, all right, next button. So if we see at this, if you refer to this table, we can clearly see that all of these plastic that emitted to the ocean is coming from river. So if you look at the number of river contributed to 100% of the waste, so it's state here 1,070, okay, or 1,070 of rivers in Malaysia that contribute to waste, okay, but for the out of that number, only 105 that contributed to 80% of the plastic. All right, so meaning that we have more than hundreds of rivers in Malaysia that contributed to the plastic pollution in the ocean. Okay, so next. All right, so where do plastic come from? Okay, like I said before, most of that coming from river. So if in common sense, so if that plastic coming from river, of course the plastic coming from land base, right? So because you use, most of us living on the land, land based application, so we emit lot of plastic waste. Okay, so and then it will transported to the river and ultimately to the ocean. So in 2021, media et al. Have reported 1,000 rivers account for 80% of global riverine plastic emission into the ocean, meaning that the river is the transporter of our plastic waste to the ocean. Next, please. Okay, so out of hundreds, 70 to 80% land-based sources. So land-based sources, the primary inputs coming from manufacture and use, or from agriculture, and then land use, and WWTP effluents. WWTP is wastewater treatment plant. So meaning that even though like for instance, we are doing the laundry, laundry, all right, and then the water that contain of fiber is a microfiber. For instance, microfiber is type of also a type of microplastic will discharge into our waterway, and then but cannot be filtered or cannot be removed during wastewater treatment plant processes. So meaning that the wastewater discharge from that still contain significant amount of plastic waste. So that will discharge into the ocean. So another 20% is coming from marine-based sources, such as fishing activities, like, or maybe shipping and so on. So this is 20%, only 20% from marine base, but majority of the sources coming from land base. Okay, so next please. So should we concern about freshwater ecosystem? Yes, we should, because I will explain using this diagram. So imagine that you have, like in environments, you throw a empty water bottle, okay, from drinking, from mineral water, let's say. So, and then you just expose the bottles under UV. So under UV and weathering process, the larger plastic, this is considered larger plastic because it's from water bottles, okay? So larger plastic will fragmented, okay, under UV, will fragmented into small plastic particles, which we call it as a microplastic. So what happened? So when they entering the river, so yeah, I mean, when they entering the river, they might fragmented, or they might be transported horizontally or vertically, depending on their density. So if the plastic is quite light, they might move horizontally, meaning that they are floating on the surface water. But if they are heavier, okay, so they might move vertically, and then they will settle on the bottom. All right. So what happened here? So let's say we have that larger particles, okay, larger plastic particles. When they are fragmented into the small particles, that small particle can captured or can be taken up by plankton, because plastic, because of their visibility, because of their lightweight, because of their color, so they are like attracting the plankton, because plankton mistakenly take them as a food. Okay, so they cannot differentiate between is that my food or that's a plastic. They cannot differentiate between that two. Okay, so same goes like for instance turtles. So turtles, they are cannot differentiate the color. So because they found that that's their food, so they are intend to get the food. All right. So what happened? So when the heavier particles will sinking to the bottom, and the lighter one will floating. But this is depend on the environmental, the surrounding environmental, meaning that they can, even though, like for instance, they are lightweight, but they also can sink if they are interact with biofilm. Okay, no, not they interact with biofilm. They interact with microorganism, and then they become biofilm. So they might settle to the bottom. Okay, so here from the plankton, so like we know that in the food web, plankton is the producer, so it will be taken up by the small fish and then big fish. So we as a human, we are ultimate user, right? So a consumer. So we will, unfortunately, if the microplastic contained in the body of the fish, so we as a human might affected with the microplastic. So bear in mind that microplastic not only because the microplastic has a large surface area, so they tend to absorb other environmental pollutant in their surrounding. Okay, so for instance, metals or POP, persistent organic pollutants, and many more. So that will change their density. Okay, and then that will change their effect if the plastic plastic transported transported up to the food chain. Okay, so that absorbing toxic substances not only can come from environmental pollutants, they might also coming from the plastic itself, because plastic, as we know, they are contain of many many others chemical, such as to get we know that plastic is very attractive. They have a variety of color, so that color sometimes are made of hazardous chemical pollutants. So that hazardous chemical pollutant, for instance, lead, cadmium, they might leach into the surrounding environment when the environmental change, meaning that their environmental their surrounding change. Maybe the pH the pH is low, or maybe because of weathering and others process. Okay, so meaning that they can taken up, or they can be vector for the pollutants. Okay, so what happened with this microplastic, some of the microplastic that are heavy, or maybe they interact with the microorganism, or they already attached with the metals or other pollutants, they might settle to the bottom and deposit in the sediment. So this is not good, especially for filter feeder organisms such as bivalve, gastropod, and so on. So because why? Because these type of organism, we as a human eat it as a whole. Compared to fish, most of the researcher, they find out that for fish, only in their digestive organ contain the highest microplastic. Okay, so we know that when we eat fish, we definitely remove the digestive organ. So we can say that eating fish is much safer than eating mussel and so on. Yeah, all right. So next, please. So microplastic can be divided into two, primary and secondary. So primary meaning that the industry manufactured the size of plastic particles between 1 micrometer to 5 mm. So this is the size that agreed by all the scientists to be classified as a microplastic. However, for the secondary, so they are fragmented, okay, in the environment, okay, because of the UV, because of the weathering process, because of the physical abrasion, and so forth. Okay, so we have two types, primary and secondary. So primary is directly from the manufacturer, and then secondary is after they have undergo certain chemicals or physical processes in the environment. So primary, normally we use it, or we apply in our personal care products, such as facial wash for the facial wash, and then for the toothpaste, okay, so something like that, okay. And then so if once you already know about this, so please after this, if you want to go to Watson or a Guardian, so please check at the back of the personal care products that you not choose the one that has microplastics. Okay, so for the secondary, like I said before, they undergo the chemical or physical processes. Thank you. So next. Okay, this is the sources of microplastic. So microplastic can be released due to the physical abrasions, and then interaction during transportation from tires, industry, plastic waste. Especially during the COVID, we use a lot of face masks that made of plastic that we throw after single use, right? So this is once they are in the environments with not proper management, they will they will fragmented into the microplastic. And then here beauty products, you have microbeads. So microbeads, the manufactured one that they are put in, the industrial put in your beauty products for like scrub and so on. Okay, and then clothing and textile. This is if you can choose cotton, but most of the, not most, I mean the type of textiles such as nylon, such as I mean from the plastic that contain plastic are much more somehow much more cheaper, and then yeah, easy to get. All right, so yeah, they will end up, they will discharge the microfiber, okay, in our waterway. Next please. Okay, so do ASEAN country participate in the freshwater studies on this emerging global pollutant? Why we call this emerging? Because everyone want to look at this, and then they have a huge impact to the globally. Okay, so here I summarize a bit on freshwater ecosystem, the occurrence of microplastic in freshwater ecosystem in Southeast Asia. So if you can see here, we have different type of sample matrices. We have surface water, sediment. So this is clearly show you that they has different size range. They have different type of microplastic. They have different range of concentrations from different place, meaning that they are varied from place to place depending on their anthropogenic sources as well. Okay, so next. So if we look at this diagram, these show that the largest emitting plastic are from ASEAN river. So the first place, if you can see, the first place is Philippines, and then followed by Klang. And then if you want to find out Malaysia, we have Langat here, Sungai Langat, and then we have Kelantan River. So next please. So this is what we have done so far in our group. We have done for Sungai Langat and Kelantan. Okay, so coming soon we will publish inshallah on Klang data. All right, so next. But I would not talking more on microplastic in freshwater, I mean in water column, okay, but I will focus on freshwater sediment. Okay, so in this study I will I find out all the literature from WOS, from Scopus, from Google Scholar. I find out that the first, the earliest year that the across the world has start with the freshwater sediment is 2014, meaning that across the world they just started the freshwater sediment research for the microplastic on 2014, but we in ASEAN country just started from 2018 onward. Okay, so if you want to compare worldwide and ASEAN data, so you can find out that very what I call it is like very limited data. We can say that very limited data that have been produced in ASEAN country. Okay, so only 17 studies. Okay, so far. All right. So next, please. So this is what I said before, how we collect the journal, the paper, okay, and then how we extract the data. So we extract based on the sampling methods, microplastic extraction, microplastic identification, and then in terms of result, we interpret in terms of abundance. We categorize based on the color, shape, polymer type. And lastly, the effect on the freshwater ecosystem. Next. So out of ASEAN countries, we have here we have 4. Okay, so only 4 ASEAN country not done any microplastic research in freshwater sediment. Okay, so from that 17 study, so we covered that 15 studies from river and then 2 studies from pond. So this is the distributions. Okay, so Thailand we have 2 studies, Vietnam 3, Philippines 6. Okay, because Philippines is the most polluted one. Okay, so Malaysia we have 4, and then Singapore we have Indonesia we have 2. Okay, next please. Okay, so this is the overview of methodology that been used in freshwater sediment. So we started with sampling tools, and then we dry the sediment samples, and then chemical digestion, density separation, filtration, physical characterization to determine their colors, their size, their type, fiber, fragment, filament, and so on. So if you can see here, even in different study, they're using different techniques of different techniques. They are using a different device of sampling tools. Okay, so they also using. For the physical, you can you read? Can you see all the notes here? Okay, so okay. So they also use the different chemical characterization for each of the studies. So that means even though they do the research on microplastic, but we we are so difficult to compare from one study to another study because of the different technique, different methodology. So meaning that we need a standardized methods. Okay, so next please. So this is the methods that they are using. So if you see from the drying, they're using, most of them using 50 degrees, but not more than hundreds. But some of the articles, they say that if you dry more than 60 degree, you might lose some of your microplastic, such as nylon. So yeah, so a lot of critical step that you need to revise, and then you need to consider, because you don't want to lose your microplastic count. Yeah, all right. So even chemical digestion, they're using a different different chemical here. Okay, so but most of them using H2O2, but some of them not using any. Okay, so H2O2 or hydrogen peroxide, they are using to remove the organic matter. Okay, even for the density separation, as I said before, the microplastic depending on the density. Okay, so if the plastic, or if the microplastic has a lightweight, they are floating. So you should choose wisely in terms of density separator. Okay, so this is, we call it a density separator. So we have a sodium chloride. So most of the study using sodium chloride, but sodium chloride, the disadvantages is that they cannot separate between they cannot separate.
Change one, please.
Okay, so
Jinuan tutup mic tu Jinuan.
can I continue?
Yes, please, Doctor. You can continue.
Okay, boleh balik pada saya punya slide tadi? Okay, so next, okay, so and then we have physical characterization. So normally we sorted here, we sorted manually same as in the literature, also using different type of instruments. Okay, so this is the summary of the microplastic in freshwater sediment in worldwide. Okay, so I just want to show you that even in the even across the other country, not only in ASEAN, they also using a different recipe, or we can say different methodology to sort their microplastic. Okay, so next. So no standardization in terms of methodology, so meaning that comparison between studies are difficult. Okay, all right, next. Okay, so this is after we gather all the information. This is the finding, the abundance of microplastic for each countries. So so we find out that we have here the highest one in Vietnam. Yeah. Okay. So but in here, even though Philippines listed as the most polluted one, but if compared to Vietnam, they are much lower. All right. Okay. So how about Malaysia? So Malaysia, we just have few studies done in freshwater sediment. Only 4 studies. So from East Coast, we don't have yet. Even in the west part of the Malaysia, this is the west part of the Malaysia, and then yeah, we still we really need to do something to get the data. Okay, because if you don't know the occurrence, you don't know how to mitigate the plastic pollution in the Malaysia. Okay, next please. So type of microplastic in terms of shape. So we find out that most of the paper agreed that majority of the microplastic is fiber type. Okay, so so fiber normally associated with textile manufacturing and laundry. So but out of 17 study, or 9 study did not report it. So this is not surprise, because during early of the microplastic studies, much of the data does not did not reported the data very comprehensively. Yeah. Okay. Next. Okay. In terms of color, we find out transparent. Okay. So almost 90% in Indonesia, 90%. We find out 80%. Sorry, 80% are from transparent palette. Okay, so normally transparent associated with food packaging products. Okay, so and then if we go to Malaysia, we find out black fragment. So if you compare from each of the colors, you find out that different country has different dominant color, and then that means they potentially have different sources. Okay, all right. So next. So type of microplastic still in colors. Okay, so blue black normally associated with the bottle caps of the mineral water bottles, okay, or fishing rope, or any shirt maybe in black color, or net, so associated with fishing activities, or white and transparent associated or linked with plastic food containers. Next. Okay, so in terms of polymer types, 8 study reported but 9 study unreported, meaning that during this even up to 2022, our review still has 9 study not reported FKTA. We can understand this because even here we are struggle to get the polymer type of microplastic, because we don't have the instrument that can occupy our needs, meaning that we need a micro FKIR. So normally we send our sample to, we outsource our sample, meaning that we sort it manually, but then we outsource for the polymer types. And then not all the studies reported each of their samples, meaning that they just get some representative samples just to see what type of polymers, okay, to get the idea that, oh, what kind of the sources that they might come from, okay. So in this case, we have LDPE, okay, so low density polyethylene, all right. So followed by okay, so low density polyethylene, yeah. So polyethylene normally with associated with food packaging. All right, next. So PE, food packaging, trays, container, sweet, snack wrapper. So maybe they are already degrade in the environment, and then they are fragmented into small plastic particles. So LDPE maybe come from wash bottles, tubing, and so on. PS from usable bag, food packaging film. Next. This is all the possible sources of the polymer. So PS, for example, polystyrene from food packaging, and then PET from bottles, HDPE from many others food and beverage containers. Next. So this is potential sources of microplastic in freshwater sediment in our study. So from that 17 studies. So the potential sources come from sewage treatment plants, okay? Discharge of sewage treatment plants, aquaculture activities, meaning that we know that aquaculture activity like blooming, yeah, because we need the protein sources, right? So imagine that in our fish contain of contaminated with the microplastic, and then we eat. So and then they are not coming alone, meaning that they bring all others harmful pollutants. So imagine what is the impact later. Okay, so other than that, tourism, and then industrialization, so for example, shipping, industrial, manufacturing, and so on. Next. So what are the effects of microplastic of freshwater organism? So from our review, most of the paper that we review did not investigate on freshwater organisms. So we need to find out separate paper that have reported on this. So from this, we find out that microplastic ingest mostly by freshwater fish, either from a wild one or from aquaculture ponds. Okay. So this is then here not only aquatic organism, the animals, also for the plants. So in here you can see the impact of polyethylene microbe on the floating freshwater plants. So they not only affected, they affected all the aquatic organism in general. Okay, so next. So this is the conclusion for MP in ASEAN freshwater sediment. So out of 17 study, only five ASEAN country has research on microplastic. So we still need more and more data from all the ASEAN country, because ASEAN country listed on the top 10 of the rank. Yeah. Okay. So and then we also need the harmonized or the standardized methodology for microplastic analysis. In terms of the microplastic, we found out that fiber is the most common shade, with PE is the most identified common plastic polymer. Okay, so anthropogenic activity affected the most. So which from tourism, manufacturing, industrialization, and from wastewater treatment. Okay, next. So way forward, we know that microplastic littering can massively happen in our country, and then with degradation of the UV, mechanical or biological. So we will unfortunately emit or will discharge a lot of microplastic in our environment. So microplastic can be detected everywhere, in our drinking water, in our air, in our food, in every part of our life. Okay, so whether we like it or not, we have to face this. So with that situation, so this will affect the I mean, when we know that everywhere contain microplastic, so it's not, we could say that we are exposing ourselves at any point with microplastic, especially in footwear. Okay, so why in my study, why I concern about sediment, because sediment compared to water, the sediment is much more greater, the accumulation, because all the microplastic with time they were deposited, and then they can resuspension, and then will back to the water column. So plus for the like filter feeder organisms such as mussel and so on, they will filter everything in the bottom sediment. Yeah, all right. So the impact of the microplastic. Can we go to the next slide? Okay. So the impact, the impact is on average, person potentially consume as much as 1,769 particles of plastic every week just from water. Imagine you got this almost 2,000 particles of plastic every week just from water. So if drinking water, you got almost 2,000. If you consume shellfish, you got 182. So if you, of course, you use salt, right, in your cooking, so you exposing yourself with 11 particles of plastic. Next. So this is just a map of average percentage of tap water sample containing plastic fibers and average number of fibers per 500 milliliter water, right? So here we can see that US is the US and then Lebanon, they are suffered from microplastic contamination in their tap water. Yeah, all right. So next. So what we can conclude here, it took you approximately 1 week to eat this credit card. So imagine that the plastic particles, if you gather in 1 week, it will become like a one credit card. So average person could be ingested approximately 5 grams of plastic every week. So our credit card, 5 grams, so that's equal to 5 grams equal to 1 credit card per week. So imagine how much you consume unintentionally, kan? Alright, so and then from that, 75% of all plastic ever produced is waste, meaning that plastic, if you produce plastic, 75% of that plastic are waste, considered as waste. Okay, so imagine how much you produce. The highest you produce, the highest the waste you produce as well. Okay. Okay, and then you have about 87% of mismanaged waste is leaked into nature and become plastic pollution. So you can't avoid this, right? So and then 1 ton the ocean will contain 1 metric ton of plastic for every 3 metric tons of fish by 2025. Imagine that later on, maybe our generation not eating fish, but you eating the plastic. So you have to think wisely for next generation. So please do something. Okay, next. So human health impact. So what is there any impact from that? Yes, not all the literature, scientific literature have reported microplastic detected in human organ. Next. In human stool, and then in blood, in human organ. Okay, first evidence of microplastic in human placenta. Even in placenta, we found it. We found the microplastic, and then this is done by our group, human colectomy. Okay, in the usus. Okay, so we still can find this. So imagine that once they are entering your body, they bring together all the harmful pollutants which have extremely bad for your health. Okay, so next. So way forward, okay, again, so once you know all the impact of the microplastic, so scientists will go for, not only scientists, well, scientists in terms of, I mean, scientists will find the solution to reduce the plastic waste. But you as individual also need to do something, okay? So what we can do is we can practice eco-friendly or green living lifestyle. We can producing biodegradable plastic. This is done by scientists or from an industrial key players, okay? Implementing eco-friendly law. So we should have a eco-friendly law. Next. So this is some recommendation that we want to highlight. So further research should quantify and evaluate the microplastic pollution with detailed environmental monitoring using standardized methodology or protocol, investigate the fate and transport of microplastic in freshwater environment, conduct a more thorough microplastic study to determine the risks that microplastic pose to aquatic life and human health. Okay, next. So I think as an individual, we still can fix this. This is the problem that we face, but we still can fix this. So what should we do? Next. So I think maybe most of us quite familiar with this. No straw. If you go to McDonald's, if you go to any restaurant and so on. Okay, next. So and then we have Malaysian roadmap towards zero single-use plastic. So this is from the government. So the implementation of Malaysian roadmap towards zero single-use plastic to reduce the use of single-use plastic, meaning that the one that you buy, for instance, the one that you buy from Pasar Malam, that one you only just use once and then you throw in the bin and then go to the landfill, and then what happened to the plastic will undergo the fragmentation and you produce more and more and more microplastic. Next. And then this initiative hopefully can be achieved, all right, by 2030, all right. And then I think for our country as well, we will not recycle. Most of us not recycle our plastic waste. So we should moving towards that, okay, to help to reduce all the plastic pollution. So next. So what can we do? You can use 7 R's: refuse, reduce, reuse, recycle, repurpose, reinvent, and rethink. I think this, as a university students, you should already know what should you do based on these 7 R. And I definitely, you must be saw somewhere or some from IG or from TikTok and so on. It's very easy. You can just type in, Google it, then you can find out what kind of activities you can do, okay, to help the earth. All right, so next. So this is some tips to reduce the plastic pollution. So bring your own shopping bags, for instance, skip plastic bag, say no to straw. I think most of us do it now. Okay, so reuse plastic, repurpose your plastic. So next. So this is at UMT, we have Microplastic Research Interest Group, MRIG. I think I need like 5 minutes more. Okay, next. So this is what we have done so far in UMT. So variety of, we are from different disciplinary, okay, different fields. So now we already research on sediment, polycates. Even now we are moving towards the solution, the nanomaterials for removing the microplastic, okay. and then fate in human. All right. So me myself now doing the not only the sediment in freshwater sediment, or I also take part in sediment in beach sediment. Okay, so for turtle conservation. All right, next. So in line with that, we have some initiative, okay, in our group. So every year we try to get some community grants to run our project, our community program. So to educate the youngster, to educate the school children, and even at secondary school, to be alert or aware about the plastic pollution. So the first our community program 1.0 with tagline "Small Hand Change the World." Next. And then the second year, this is led by Dr. Noorlin. Our tagline is "Small Act, Big Impact." So we hope that with small act, but will bring a huge impact. Next. So this is the latest one. This is led by me. Okay, so with tagline "Think Green, Keep It Magically Usable." So what we did here, we try to implement 4R, meaning that reduce, reuse, recycle, and repurpose. So in this community program, we approach the youth for joining our program. So we give their like lecture on plastic and microplastic pollution, and then we have they have experiential learning activity such as producing the idea craft. Okay, here if you can see the pasu angsa, okay, swan, all right, and then they made eco brick that can be transformed into like maybe tables and so on. Okay, and then we have also some other upcycling activities. All right, so we hope that with our small initiative within our community, so we can help to reduce and to educate especially youngster to be more responsible to our earth. All right, so next. So I think that's before I end my talk, I think if you have any question or you have any maybe you want to do some research or some studies, feel free to contact us, okay, via our email, IG, or Facebook. Okay, next. So last but not least, I would like to acknowledge, I would like to thank all the MRIG members, University Terengganu, Faculty of Science and Marine Environment, my master and FYP students, and the KPT grants, FRGS, for supporting my research so far. Okay, so with that, I think I will end my sharing. So hopefully that it will give you benefit. If not today, maybe later. Okay, so thank you.
Okay, thank you so much, Dr. Maisarah. Right, thank you for educating us on maybe some of us have not realized that our normal activities can bring or can contribute to these microplastic problems. Okay, and this can have a great impact to the to our environment, and at the end of the day it come back to us and affects our health. Yeah.
Yeah.
All right. I saw some questions being asked by the students in the
I just read
in call
that.
messages.
Yeah. Do you want
Can
me
I
to
read this?
Yeah,
Okay.
no, I can saw the question. You want me to answer now?
Yeah, maybe we can entertain one or two questions before we
Okay.
move to Dr. Noorlin.
All right. So I think here we just have 3 questions. So this one of that Muhammad Karim he asked me about if the plastic coming from the river. So do we have any technology? Yes, we have. In Klang River, we have the intercept. We call intercept, if I'm not mistaken, right, Dr. Nolin? I'm not really remember the name, but I think they call it as intercept, right? So the intercept is the intercept is used to track all the plastic from the Klang River. Because we saw that intercept during our sampling in Klang River. So we have the technology, but the technology is from other country, from Germany. Okay, so Malaysian itself, I have no idea. Okay, so here is Tai Eng Kim. He or she asked me, I cannot understand why ASEAN produce 70 to 80% microplastic pollution while developed countries are high consumption in nature. Yes, because although they are consume much higher in nature, but they manage their plastic waste properly. Meaning that just for instance, in Malaysia, we have only like, if I'm not mistaken, we just have like maybe 110 of landfill. But out of that 110, not all are functioning. That is one reason why our waste management is not comparable to them. All right. So yeah, even China, if you remember my diagram before, China out of 51%, China contribute 31%, but in terms of the rank, they are lower than lower than Malaysia, right? So Malaysia rank upper than them. So I mean on the top than them. So that's mean the waste from their country, they can manage properly better than us, because they normally, all the developed countries, they are rich, so they have money, they can deal with their waste properly, plus they might send or they might export the waste to other country. That's happened to us. We are accepting the plastic waste, right? Previous years. Okay, so and then practice 3R more intensively. Yes, we should practice not only 3R, 4R, 7R, but the thing is, it's not easy. It's not easy in community level. You want to educate, and then you need really strong courage to do even 3R. Because because for your information, up to now, our country just managed, the percentage of the recycling rate in our country just not up to 40%. We want to achieve by 2025, 40% of recycling rate, but now we just only like 30 something, 33 if I'm not mistaken, something like that. So imagine we have like 2 years from now, but we need like, yeah, you as a orang bijak pandai, so you should do something for your next generation. Yeah, all right. I think that's
maybe
all.
maybe Doctor want to entertain one more question from, we have DOE person, Mr. Ramli Manak here. He is asking on DOE imposed EIA for plastic. So he wants to know what is your comment on that.
Mr. Ramli, thank you for the question, but I'm sorry, I'm not like EIA person, but I think this is Dr. Noli is the best person to ask, because she quite expert on the EIA. Yeah, Dr. Noli, can you?
Okay, maybe later after
Sorry,
Dr. Noorlin
I
talk.
think this one also I cannot answer the question. Sorry.
Yeah.
Okay. Mr. Ramli, sorry for that ya. Mr. Ramli, maybe apa ni doktor
Yeah, I'm so sorry to disappointed you. But honestly, I don't have any idea on that. But I'm sure to to ask my colleague in the
Yeah.
team if they know. Okay, and then I will get back to Dr. Sarah if possible.
Okay, thank you, Dr. Sara.
Okay.
Right.
One question.
Okay, yeah.
Can I ask one question to Dr. Maisarah?
Okay, go ahead, please.
Okay, Dr. Maisarah, my name is Noorlin.
Yeah.
Regarding microplastic in our drinking water, so we have a lot of water filter like Coco, Kowe. So do you think that kind of water filter can help us to reduce the microplastic inside our drinking water?
Yes and not. Why? Because in our team, we done several analysis using Kowe water filter. So we find out no microplastic in that, but maybe nanoplastic. We don't know. So that is why my answer is yes or no. Does that make sense, Dr. Knowledge?
No, that's true. Like because we analyze only microplastic,
Yeah.
not
Yeah.
nanoplastic.
Yeah. So we don't know whether maybe that filter just filtering the micro but not filtering the nano. So we don't have any idea on that. So for now, we have several tests on the water from Kuwait, but we found out no microplastic, but we not sure whether it contain nano or not.
Yeah, but in terms of quantity, maybe we can we can a little bit relief lah.
Yeah. In terms of in terms of
Quantity.
quantity, yeah. So what I did after that, I like I'm using all the filter water to cook the rice and everything. So yeah, just to relieve my, I mean, like just to make myself happy that I'm not consume microplastic. Yeah.
All right, thank you so
All
much,
right.
Dr.
Thank you.
Maisarah, for the very interesting talk. Okay, so now let's move on to Dr. Noorlin. Okay, Dr. Noorlin, the floor is yours.
Entire screen. Share, cancel. Kejap
Okay, Dr. Noorlin will be talking about the microplastic in atmosphere. So apart from sediments and fresh waters, they also have done some research on the microplastic presence in atmospheric. So let's hear what are the findings from Dr. Noorlin.
Okay, can you see my screen now?
Yes.
Okay, Bismillahirrahmanirrahim. Okay, so my topic today is microplastic in the air. Okay, I'm Noorlin Binti Mohamad, one of microplastic research interest group member. Okay, okay. Boleh nampak kan Kak? Doktor? Sarah?
Yeah.
Okay.
Yes, boleh.
Okay. I'm not familiar with this Google Meet actually. Okay. Right. So we move to the next slide. Okay. I think Dr. Maisarah already introduced our team member. Okay. This is our team members. Okay. And she also mentioned about our research interest in MRIG, right? Okay. Some of our members conducted research on biota, water, sediment, air solution, and also the solution for microplastic pollution. Okay, so me and one more of the member, Dr. Kukausa, focus on airborne microplastic. Okay, next. Okay. A little bit intro lah about our MRIG punya work. Okay, so at MRIG, we conducted research and development, consultation, and also corporate social responsibility as mentioned by Dr. Maisarah previously, right? Okay, so in terms of R&D, so we focus on occurrence, distribution, identification, and also possible solution for plastic and microplastic debris pollution. And for consultation, we are involved in giving training on microplastic sampling in different medium matrices to some of government agencies such as NAHRIM, FRAME, and ALS also. And then for the CSR or so-called knowledge transfer program, Dr. Maisarah already mentioning about our knowledge transfer project, which we secured a grant, knowledge transfer assimilation grant, knowledge transfer assimilation grants from UMT for 3 years in a row. Okay, then we um, um, we conducted program with the communities on plastic debris awareness. Other than that, we also conducted exhibition, public talks, and also sometimes ada juga kita boleh kata some it's not some teachers from secondary school call us to give like a sharing session about this awareness program. Okay. So back to business lah. So I want to talk about my it's not my interest in microplastic airborne. So first of all, if you can see from this slide, okay, according to OECD report in this year, okay, the global plastic estimate that the global plastic waste projected to almost triple by 2060. Okay, so here we can see that kita punya plastic waste become increasing, right? Okay, and then we know that this is due to our economic and also population growth. And then plastic pollution will persist for many years due to high durability of plastic, and this can result or can cause animal injury and death, public health hazard, and also aesthetic degradation. Okay, in general, okay, we can say that most pollution comes from microplastic, but yet the problem of microplastics cannot be ignored. Okay, so what are microplastics? So we know that large plastics slowly biodegrade or break down into small particles in the environment. Okay, and the plastic particle which is less than 5 mm, we call it as microplastic. Okay, and then there are two main types of microplastic. I think Dr. Maisarah also talking about this, right? So we have primary and also secondary microplastic. Okay, so for primary, this microplastic actually purposely made for particular application, such as for use in cosmetic products, textile industry, and also industrial materials. Okay, and then meanwhile for secondary microplastic, this microplastic are particles that are formed as a result of breakdown from larger particles, larger plastic particles in the environment due to, or we can say that when the microplastic exposed to several physical and chemical processes, environmental processes, so they fragmented. Okay, like when the plastic exposed to sunlight, wind, rain, or other environmental condition, then the bigger plastic can become secondary microplastic in the smaller particles. Okay. Okay. To date, the majority research of microplastic in Malaysia, okay, has focused on the marine environment, rivers, lakes, and other terrestrial environment. Okay. In this slide, okay, even in Malaysia, you can see that here the occurrence of microplastic has been reported in several publications. Okay, but still the study on microplastic in the air or atmosphere is still limited. Okay, then we can see here microplastic also among the most prominent environmental problem, and we can see here that due to their small size, microplastic considered bioavailable for organism throughout the food webs, and without proper management, primary microplastic can be released into the water, then can be formed secondary microplastic, and lastly can be ingested by marine organism, and finally this microplastic will transfer to us human via food chain. Okay. All right. In terms of microplastic in the atmosphere, so how do microplastic become airborne? All right. So due to their small size, okay, and also low density, this microplastic can be easily suspended and resuspended, and easily can be picked up by winds and blown around the world and potentially transferred to the air, and again easily transported by the wind, and at certain time this particle will fall back into the freshwater system and also the ocean, as well as the terrestrial ecosystem. Okay, this is by process of dry and wet deposition. Okay. Right. This is the importance of why we are concerned with the airborne microplastic. Okay, because we know that microplastic are everywhere. Okay, then due to their small size, lower density, so they can transfer by the wind. So at the same time, actually we are now inhaling microplastic as well apart from other pollutants. Okay, and then our concern here, microplastics can be inhaled due to their small size, same as like other particles which size lower than 2.5 micrometer, and with this smaller size or the particle size lower than 2.5 micrometer, uh, this particle actually can enter our respiratory systems and remain in our lungs, which can cause respiratory problems. And with the smaller size and their height surface area, this microplastic actually can act as a potential carrier for spread or accumulate the organic or inorganic contaminant. Okay, so in this figure, okay, it shows that the implications of microplastic inhalation and also the possible consequences in human respiratory system um, due to microplastic inhalation. Okay, so from here we can see that as atmosphere was identified as important pathway of microplastic, so it is necessary to gain a better understanding of the concentration and also sources of microplastic in atmospheric. All right. Okay. So previously, I do mention that microplastic research focus on the marine environment, rivers, and other terrestrial environment, right? So in 2015, so microplastic were detected for the first time in atmospheric precipitation. Okay, so this is the study by Dries et al. Okay, um, and then so what is more worrying in airborne microplastic or microplastic in the atmosphere is because microplastic also have been found in a remote and also in uninhabited regions, such as this is the place lah, they found microplastic in this remote area. So this is some article about that. Okay. Right. And then one more place. Okay. Microplastic also have been reported in Mount Everest. Okay. And here we can say that microplastic pathway through atmospheric transport and also deposition. Okay. This is because we know that the nature or characteristic of microplastic itself because due to their smaller size and also lower density, so that they can easily pick up by wind, right? Okay, and here you also can see that they report the possible sources of microplastic, maybe other than from other places. Some of the activities on the Mount Everest itself also contribute to the concentration of microplastic, such as climbers' clothing, climbing gear, and others. All right. Okay. So here we can see that the number of publication about atmospheric microplastic since 2050. So the studies on airborne microplastic have dramatically increased. Okay, because uh, from the study, they say that atmosphere is a reservoir and superhighway through which large amount of suspended materials are transported. Okay. Okay. Here are the main sources of microplastic in the air. So I choose to conclude the sources of indoor and also outdoor plastic debris. Okay, so we can see here some of the sources like industrial processes from 3D printing, this one like primary microplastic, and then from the synthetic fabric cloth, from the outdoor we have road dust, wear and tear from vehicular tires, from microplastic litter, from landfill, and also household object. Okay, and so this microplastic will experience the photochemical reaction under sunlight irradiation, and then this airborne microplastic could decompose, and so what else? So it exhibit diverse morphology such as fibers, films, and also fragments. And at the same time, due to their small size with the bigger surface area, so they can absorb chemical like inorganic or organic contaminants, so they can release chemical additive and others such as monomer. And lastly, this can affect human health. Okay. Right. In terms of health impact, So the potential routes and effects of microplastic in human, we can say that we have three categories of pathway or potential routes that microplastic can expose to the humans. Okay, here first we have inhalation. So this one is very crucial. Uh, this is through respiratory exposure, where we can see here that the transport of inhale airborne microplastic in lung depends on size, and the microplastics have the potential to penetrate into deeper parts of the lung. And compared to the ingestion pathway, the amount of microplastic have 3 to 15 highest in inhalation pathway. Okay, for the ingestion pathway through food consumption. Um, in the literature search, okay, microplastic have been reported to be detected in various foods or drinks, such as seafood and also uncovered food, and these can impact the food security, safety, and also human health. And furthermore, through fallout on skin, so this pathway can be considered as a less significant pathway. So if you can see here, only particle with sizes below 100 will be directly absorbed, so making it difficult for most microplastic to absorb through the skin. Okay. All right. Then, okay. Wait. Okay. Before that, okay. As I mentioned, actually each of these route of exposure is related to a particular environment and also its chemical physical characteristic. Okay, and then sorry for that. Okay. Okay, here studies on inhalation of microplastics show a series of adverse effects along the respiratory tract and beyond, ranging from irritation to the onset of cancer in cases of chronic exposure. So these adverse effects include immediate asthma-like reaction, inflammatory reactions like chronic bronchitis, lung disorder like chronic pneumonia, causing difficulty in breathing, and also autoimmune diseases. Okay, I'm sharing here the figures where microplastic get trapped in the human body. So when inhale, microplastic circulate through the body and get trapped in various locations based on their sizes. Actually, this mechanism seem like uh, the particulate matter. Particulate matter. Okay, we can see that plastic which greater than 5 micrometer can become trapped in the upper airway, and then the particle with from 1 to 5 can be deposited into the lung, and lastly less than 500 nanometer interfere with uh, this condition. Okay. Okay, now we move on to research on airborne microplastics. So here I'm sharing some of the findings from the previous research about microplastic contamination in outdoor environment. Okay, so normally we recorded the finding about microplastic in terms of their concentration uh, and also their characteristic, physical and chemical characteristics. So here we can see the concentration measured, their size, shape, polymer types, colors. Okay, in terms of shape, actually in airborne microplastic or microplastics in the atmosphere, um, the fibers shape contribute the most significant, or we can say that the most dominant shape in the atmosphere. Okay, and for the color, sometimes some study reported that they find blue to black color, but other study reported white or transparent color as the dominant color for microplastic in the atmosphere. So this is the finding for microplastic contamination in indoor environment. Okay, so here the fiber shapes also contribute uh, as the dominant shapes. Okay, because we know that some of the fibers can come from our clothes. Okay, all right. Okay. Now I would like to share my case study lah. My case study. Okay. Which this is a preliminary study by our group, still unpublished. Okay. We conducted study on microplastic in the atmosphere. In the outdoor and also indoor environment in University Malaysia Terengganu. So as I mentioned before, we detected the presence of polymer fibers in the air. So you can see here the examples of image of microplastic from airborne samples that we get from the outdoor and also indoor. Other than that, actually, we also found that fragment shapes in our samples. Okay. Then when investigated, plastic particles are found in every samples that have been taken. Okay, and in our study, we use or we applied passive sampling. Okay, actually, for your information, uh, for sampling in airborne microplastic, we do have two sampling approach. We have first we have active sampling and also passive sampling. But in our case, we applied the passive sampling first. Okay, and from there, we try to categorize or we try to classify microplastic in terms of chemical composition, color, and also shape. Actually, this is the common type of microplastic classification, and also common finding for chemical composition, for color, and also shape. That can be found for studies such as here for chemical composition, PE, PP, PET, PS are polymer types that that commonly found for microplastic samples. And in terms of color, black, blue, yellow, green, white, and transparent. And for the shapes, it's normally we found fibers, fragments, film, forms, and spheres. Okay. And then the possible sources. Okay. In our study, we we assume is we assume the possible sources of the airborne microplastic based on the result of polymer types PP, such as PP can be from rope, bottle caps, or netting, and PE from plastic bags, netting, or drinking straw. And lastly, PES from clothing and or furnishing materials. Okay, and here we have SEM image of the microplastic samples. So here we can see that from first figure, there are cracks here. Okay, it's showing us that this microplastic or microfiber was in the atmosphere for a long period. And then second picture, show us tiny fibers observed to be attached or sticking on the microfiber surface. And then third figure, we can see the presence of crack due to mechanical or oxidative weathering process. And lastly, here we can see the round shape of biofouling. Okay. Okay. So as a conclusion here, we can see that microplastics are influenced by the community lifestyle choices, anthropogenic activities, and also meteorological condition. But in our case, the meteorological condition is not recorded during that sampling. Okay. And then we found the most dominant shape fibrous microplastic, and the morphology studies give an idea that surface chance provides a good medium to serve as vector for other types of pollutant. And I think during Dr. Maisarah presentation, she kept mentioning that we still don't have standardization in sampling methods. Okay, so it's hard to us to compare, to do the comparison properly, and it's like quite difficult to compare with the other studies. So standardization of airborne microplastic sampling method is needed to optimize the effectiveness of future works in this area. I think that's all from me, because the way forward for microplastic pollution punya reduction pun, I think it's same like the same like sharing by Dr. Maisarah previously. Okay, and for the acknowledgement, I would like to thank you all the MRIG members, my FIP students, UMT, our Faculty of Science and Marine Environment, and also my supervisors from Atmospheric Chemistry and Air Pollution Group from UKM. Okay, I think that's all for from my side. This sharing. Okay. So,
Much
thank you.
Right,
Okay.
thank you for the very interesting explanation on the atmosphere. Maybe we can entertain one or two questions from the participants. Maybe if you have any questions towards Dr. Noorlin, maybe you can use the raise hand button there. Okay, maybe we will start with my questions, Dr. Noorlin. I just want to know why color is important in microplastic studies or analysis. What does color signify?
Sorry, Dr. Sara.
Okay. Why color is so important in microplastic analysis?
Okay.
What does color signify?
Okay. Actually, is it right you're asking about why the color is important in this analysis, this microplastic analysis, right? Is it?
Yes, that's true.
Okay. All right. Okay. Actually, some of the study said that the color can determine the color because the color can we can know the sources from the color actually. Okay, but dia agak tricky jugalah bila we said that the color can boleh jadi digunakan untuk pengenapastian sources, sebab we know that bila microplastic berada di environment, dia dah melalui several process kan. So boleh jadi dia jadi discolor balik sebenarnya, discolor, then dia tak dapat original color. Okay, itu sebab some of the study dia cakap okay, if indoor ada study yang cakap they found black during during ada season lah. Then dia cakap that itu menunjukkan pakaian yang dipakai pada waktu season tersebut. So dia macam cakap okay, they conclude that the colour represent the attire that they wore during the seasons. Okay, sebagai sources. But then other than the sources, okay, selain daripada kita nak identify the sources, sebenarnya colour juga penting sebenarnya untuk pengenapastian colour, sebab sometimes bila kita kena pasti colour pun memainkan peranan penting jugalah, sebab colour kita kata the organism can be mistaken the food based on the colour of microplastic. Okay, alright.
Alright. Thank you, Dr. Ronaldo.
Okay.
Because of sometimes colour ni, when it goes, especially analysis kan, analytical treatment tu, even when we are using H2O, hydrogen peroxide, dia boleh discolored juga kan.
Betul, discolored. Yeah, that's true.
So there are questions from the chat box. Yeah, we read them to you, Dr. Noorlin. The first question is, what can we do to ensure the prevention of microplastic from coming into contact with us? Would wearing a face mask be sufficient enough?
Okay. What we can do to ensure the prevention of microplastic from coming in contact with, okay. Actually the usage of face mask dia sama je dengan macam like kita ada haze kan, during haze ataupun during like air pollution lah kan, air pollution, so sama. So sebenarnya dia akan bergantung kepada kita tengok balik the size of microplastic, the size of particulate matter with our face mask punya size lah. Okay, tengok kesesuaian tu balik lah. Jadi I think in this case, wearing face mask boleh jadi kita kata can be sufficient lah.
Maisarah, thank you. Or you have any question, Maisarah?
Tak, sorry, saya tertekan. If I may add some of the points from Dr. Noorlin.
Okay. One more question from Mr. Ramli from the OE. Plastic converted to resin process are policy to emulsion. What is the comment? The plastic converted to resin, I don't think so. Maybe resin convert to plastic. Cool. Dr. Ronaldo, do you have any comment on this? Maybe dia punya soalan ni macam plastic fraction cukup converted making that process. Any comments from Dr. Ronaldo?
Alamak.
Betul ke Mr. Ramli? Do you mean that dalam penggunaan resin in plastic making processes, there might be some emission, some plastic fragments emitted to atmosphere? Dr. Noorlin nak komen? Saya kurang faham juga soalan ni.
Okay. Become plastic converted to resin process become polluted to it. That's what is your
Maybe saya boleh tolong jawab kot.
Okay, Dr. Maisarah.
Okay. Kalau lah sebab apa yang saya faham betul lah kan. Sebab plastik ni memang dia dia memang made of resin sebenarnya. Yang saya kata tadi itulah yang they have like macam harmful hazardous pollutant, sebab dia membentuk plastik ni dia terbentuk daripada rantai-rantai dari molekul yang panjang tadi. Dia ada juga additif tau yang diletak. So additif tu biasanya dia jadi dia resin lah. So resin nanti yang akan kalau dalam environment bila dia dah interact dengan macam-macam lah kan, maksudnya environmental factor, maybe dia boleh leach out lah. So if I'm not mistaken, kalau betul lah apa yang saya faham apa soalan dia tu, meaning that let's say kata rasa samalah dia punya impact tu. Maksudnya kalau microplastic tu dia adalah dia vektor kepada banyak jenis pollutant juga. So bukan sekadar dia dia bukan sekadar dia bring others pollutant bersama dengan dia, tapi dia juga distribute pollutant daripada plastik tu sendiri kepada environment sekitar dia. Itu maksud saya. Boleh faham ke?
Okay, saya faham.
And then kalau boleh saya nak tambah sikit yang Dr. Noorlin cakap tadi. So macam yang doktor ada tanya tadi pasal yang colour kan. So that is why bila kita buat microplastic analysis, kita akan buat juga bersama-sama dengan SEM EDS contohnya kan. SEM kan kita nak tengok morfologi dia so that kita boleh predict lah whether that microplastic sebenarnya discolor because of the age ke ataupun macam mana. So kita boleh tengok lah sama ada dia ni memang virgin ke ataupun dia macam kita boleh predict lah. Kita cakap tak adalah boleh exactly dia tu kita boleh kata dia ni memang virgin ataupun dia memang age punya microplastic. But kita ada some idea lah, boleh tell us kalau ada crack apa maksudnya, kalau ada kalau ada dirt maksudnya apa, mungkin ada interaction dengan dia punya pollutants ke whatever kan. Kalau kita buat EDS mungkin kita akan dapat metals yang attached dekat dia punya microplastic surface. So I think this colour sometimes that is why bila kita dapat transparent tu kita kena buat jugalah follow up lah dengan SEM lah. Biasanya kita memang buat lah SEM tu, kita nak tengok morfologi dia lah. So tapi saya memang setuju jugalah dengan Dr. Sara cakap tadi yang discolor boleh berlaku kalau kita guna hydrogen peroxide lah. Even kalau kita tengok macam saya punya yang study saya tadi pun, bila saya buat review tu, none of the study have done the QC. Kan? Tapi kat kita memang ada buat QC lah, maksudnya kita memang ada buat all out lah daripada from the beginning until the end of kita punya analysis. But kalau ikut dalam yang published literature, yang Kendian ni banyak lah yang buat QC juga. Tapi yang previous years tu banyak yang tak buat pun QC. Meaning that kita tak tahu whether microplastic memang is come mainly from dia punya, originally from dia punya sample matrices or dia dah contaminated with the atmospheric punya microplastic. Kan?
Yeah, true.
So
macam
why bila kita ada QC tu, kita lega lah sikit kan. Bila kita buat QC tu maknanya kita akan buat dalam satu macam glass box ke or something yang kebok yang kita macam like kebok asap lah, like macam yang tertutup sikit lah masa kita buat sorting tu kan. Macam tu lah. So that kita boleh minimize the interaction lah kan between kita punya yang place. Even masih kalau kita buat analisis tu pun kita tak boleh nak pakai baju yang daripada ada sumber plastik kan. Kita kena pakai cotton dan kita kena ada langkah berjaga-jaga lah maksudnya macam tu lah.
QC.
Tu saya rasa itu je lah kot saya nak tambah.
Thank you so much both doctors. And Tai and Lim ada tanya juga on why there is no standardization in the MP test. Maybe dia termiss lah Dr. Maisarah punya explanation just now. Okay, Dr. Maisarah nak explain kembali ke secara brief?
Standardization tadi bila macam mana soalan dia?
Why no standardization in MP test? Might have a missed answer. Is there any standard minimum MP in air and water?
Okay, so kalau untuk yang Southeast Asia, kita ada Westpac sebenarnya. So kita ada Westpac ni dia memang negara-negara Southeast Asia lah kebanyakannya, dan two members of our MRIG sebenarnya adalah ahli Westpac. So apa Westpac ni buat, dia kumpulkan semua saintis daripada Asia country lah, if I'm not mistaken. I tak tahu, tak ingat lah kalau ada Europe pun ada juga. Tapi this is dia kita apa kata initiated by China lah kan. So before COVID memang every year dia orang ada memang ada buat bengkel bersidang and so on lah. So dia even China pun memang ada key laboratory of microplastic analysis. So what they do adalah they try to collect together all the data, tapi all the scientists or dia punya ahli tu must using the standard methods, maksudnya method by Westpac. So that nanti bila kita dapat result, kita senang nak compare, because kalau kita tengok literature sekarang, dia tak standardized. Sebab apa? Bila kita sampling dah lain, so bila sampling lain kita dah pengiraan pun dia akan lain, and then bila methods yang lain pun kita dah tak dapat nak compare secara ni lah, secara baik lah unit pun lain. Jadi kalau kita convert pun betul ke the way kita convert tu kan, sebab kita tak tahu dan kita tak buat that analysis yang daripada previous study ataupun ada study tu kan. Jadi kita based on assumption lah, okay kita convert. Biasanya bila kita gather all the information, some of the data memang kita tak boleh nak convert pun to the similar punya unit. Kalau kita tak boleh nak convert similar unit, then kita tak boleh nak compare kan. Sebab microplastic ni dia adalah physical pollutant. Dia chemical, tapi dia dalam bentuk, kita reporting dia dalam bentuk unit yang physical kan. Dia macam contohnya item water, atau tidak macam metals concentration memang ppb level ke ppm level ke macam tu kan. Jadi that is why I think sebab tu yang dia jadi susah kita nak standardize tu. Saya rasalah pandangan saya. Mungkin Dr. Noorlin nak tambah?
Dr. Noorlin, kita nak tambah.
I think I agree with Dr. Maisarah lah kan. Okay, other than that, mungkin kita kata this lack of standardized method ni pun sebab we are shortage of the knowledge on chemical composition such as molecular weight of plastic polymer itself, and also I think kita tak ada knowledge yang banyak juga lagi lah according to interactive roles between physical, chemical, biological, semualah yang berkenaan dengan microplastic ni kan. Sebab kalau nak bercakap pasal standard pun kita pun still dekat Malaysia pun kita tak ada lagi standard berkaitan dengan microplastic kan. Sama ada dalam in air ke atau in water ke, semua tu lah maknanya.
So the closest we have is the standard from Westpac lah kan?
Yes. Untuk yang Asia country lah.
Alright, I think that's all. I think it's already 12 o'clock, 12 noon. So rasanya maybe kita wrap up lah for this topic or this webinar. Okay, thank you again for all of you for attending today's webinar. That we have talking about the almost 2 hours, more than 2 hours lah, on the overview of microplastic in freshwater sediment and also microplastic in atmosphere. Hopefully throughout the session, okay, we gain some insights into the presence, sources and impacts of microplastic in these two important environments, freshwater and also atmosphere. As we conclude this webinar, we can say that it is evident that microplastic presents significant challenges in both freshwater sediment and juga atmosphere. So it is essential to continue research efforts, develop robust monitoring systems, implement effective mitigation strategies, okay, in order to address these microplastic issues. And then one more thing is raising awareness is also important. Okay, maybe some of us can become the macam duta lah in promoting sustainable practices and advocating improved waste management. We can both all together work towards minimizing the release of solid waste, most importantly the microplastic into environments, and also safeguarding the ecosystem. Thank you again for all of your active participation. And let us continue collaborating. Okay, maybe we can collaborate further with UMT and also UniMAP. UniMAP pun ada juga
Boleh,
buat
insyaAllah.
research on microplastics.
I tu dengar Dr. Sara nak jemput kita pergi UniMAP
Itulah. Boleh nanti next time.
Okay, insyaAllah sampai playlist kita.
InsyaAllah kita jemput nanti tengok kita dah ada a few samples lah yang kita dah go through. Kita ada micro raman kat sini.
Yeah.
Raman. Okay.
Actually sampel yang Dr. Sara sendiri pun kita dah ada dah. Ya, tunggu untuk kita pergi further analysis je lah untuk sebab hari tu SEM dia orang minta buat lepas raya kan. SEM and also FKTA lah. Memang banyak lah. We found
itulah maybe nak discuss further lah dengan both of you on the results juga. Okay, nanti mungkin kita in future kita akan inilah. Okay. Alright, thank you so much to both doctors and thank you for those participating. I have put the attendance Google form in the chat box. Okay.
Dr. Sara kena bagi ni, kena bagi token ni dekat yang student yang aktif ni. Saya pasang tadi dengan Khairin kan.
Khairin dengan Anglim ni. Kita bagi reward lah kat dia orang.
Betul.
Alright. Okay.
Okay, selamat Hari Guru.
Selamat Hari Guru.
Alright.
Thank you for inviting us.
Okay, bye.
Yeah, Mr. Ramli mana ada attendance kat situ. Sign up the attendance and immediately